Hello everyone, today we'll be performing the AM transmitter experiment of analog communication. So this experiment is basically to generate an AM and transmit it. So the first step towards this experiment is switching on the power supply. Okay, that's very easy. So let's move forward. First we need to see what our signal generator, modulating signal looks like. So for that, there are two knobs present over here. One, this is for adjusting the frequency of modulation signal, and two, this is for adjusting the amplitude of modulation signal. We'll connect the output of the modulating signal generator to our probe. We're connecting the red wire to the red, and black is gonna be our ground. This wire, the probe, is going to be attached to our DSO. Press auto set, and here is our modulating signal. Now just measure what are the attributes of the signal. So the signal is 1.46 volt peak to peak, and the frequency of this is around 6 kilohertz. Let's reduce this frequency to around 1 kilohertz. So for that, I'm using the frequency knob of our board and reducing the frequency. So finally, the frequency of our signal is going to be of 2 kilohertz, and the amplitude will be of 1.48 volt. So moving forward, we need to find the carrier frequency. So finding the carrier, you just need to connect the AM output to the input of the auto set and measure. As we know, the range of AM signal is 535 kHz to 1605 kHz. So it is mandatory for us to keep the FC somewhere in that range. So for that reason, I'm going to change the carrier frequency adjustment knob over here. By changing the knob, I'm keeping the frequency as 700 kilohertz. So with this, we'll just note down the value of the FC frequency, FC. Now, the next step is to find the DC bias. For finding DC bias, we need to use the multimeter. So we'll connect the DC bias terminal over here and ground. So as you can see, the DC voltage is more than 8, or it's around 9 volt. So we'll be reducing it to 8 volt. Yes, the DC bias has been set to 8 volts. Now the next step is to create an AM signal. For making the AM signal, we need to connect the output of the signal generator to the input of AM generator. After connecting this, we can find the AM signal. So for seeing the AM signal, we have to join the AM output to our probe for DSO. I'm changing the time scale so that we'll be able to see the AM wave properly. Now this wave is a bit distorted, so we have to check by setting the amplitude of the modulated signal, we can make it proper. And to get a proper waveform, we can also change the carrier frequency a bit. By changing it a bit, we will get a proper waveform of AM. So this is our AM signal. Now the most important part of this experiment is to operate the spectrum analyzer. This is our spectrum analyzer. Just remove the probe and place it over here. There's a small change involved while taking the reading on spectrum analyzer. That is, you need to use the power amplifier. The connections are again very simple. Remove the AM output and place it at the output of the power amplifier. Connect the AM output to the input of the power amplifier. So with this, all your connections for this experiment is over. You just need to find the readings of the spectrum analyzer. Now we'll begin the most important part on how to work on spectrum analyzer. As we have measured that we have set the carrier frequency to 700 kilohertz. So we need to place the 700 kilohertz on the spectrum analyzer. For that, just press the first button, which is for change the frequency. When you click it, you'll get a center frequency and the value which you can change variably over here. So input your carrier frequency as 700 kilohertz. Now, as you can see, there's only one waveform, one spectrum available. But for spectrum of AM, we should have three spectrums. Like one is FC, FC plus FM, and FC minus FM. So where is it? The thing is that all the three spectrum is actually present in this waveform. The distance between the two, which is FC plus FM and FC minus FM, is less. Because of that, we are not able to differentiate between the spectrum. So how to change it? Changing the frequency of FM. I'm increasing the frequency of FM. After observing the spectrum, we need to place markers on the spectrum. So to place the marker, press the marker button on the spectrum analyzer. It is the second last button on the spectrum analyzer. The moment you press it, you'll get a marker which is going to point at the peak of the spectrum, and it is type magnitude. You need two more markers for USB and LSB. So for that, you need to use the new marker button. The second marker is directly placed at the second peak after peak, second small peak. So it is of type difference, but you need marker of type magnitude. For changing the type, press the marker type button. So you are having marker M2, which is of desired type. We need another marker, so press at marker again. You'll find new marker on the screen. Press it, and you're getting the third marker, which is again of different type. You need to change it to magnitude type again. So change it or press the marker type button. So with this, you have placed all the three markers required for this experiment. The next is you need to find the power at each spectrum over here. To change it, press the amplitude button. It is the third button on the spectrum analyzer. The moment you press the amplitude button, you'll get the options as reference level, range or reference position, unit, reference offset, etc. Press the unit over here and change it to watt. Enter. So now you are able to find all the power which is present at this position. First of all, and after this, you need to make the change that this spectrum should be of type amplitude modulation. For that, press the measure button. It is the sixth button on the spectrum analyzer. Once you press the measure button, you'll get measure mode. Click on it and go to amplitude modulation depth. So it will do some screening and you'll get all the perfect spectrum. But as you can see, the markers have been again changed to D2 and D3. You need them of type M. So again click on marker, press select marker. Now it is at D2. Now press the button marker type, which is now changing to M2, and again press select marker. Now it is pointing at D3. Change the type of it to M3. So with this, you are able to find all the position, the amplitude modulation, which is at the moment around 60 to 70%. To get the final output, press the button sweep and press single sweep. By single sweep, it will just pause it for momentarily, and you can find the modulation depth, which is in this case 63.66%, and the values at the marker. Now, if you check the observation table, the table consists of modulation index, US power, LSB power, carrier power, and total. So by checking the power at the marker respectively, you can find the power at each position. Now, for the next reading, you need to change the modulation depth. The modulation depth can be changed by changing the DC bias. This is the DC bias of the circuit. By changing the value, I have changed the value and continuing to sweep the value, thus you can see the variation in the spectrum. Now, you can just observe, as I'm changing the value of DC, the modulation index is changing and the spectrum is also becoming different. So by changing the DC bias and by using the sweep function, you can single sweep it and find the values of modulation index, the LSB power, the USB power, the power of carrier. And repeat this by changing the DC value again and again and find 5 or 6 readings. So this is how you are supposed to perform the experiment of AM transmitter. Thank you for your time.